How do you calculate days of autonomy for an off-grid system? Imagine you're planning a remote cabin getaway or setting up a solar-powered tiny home. How do you make sure you have enough energy when the sun isn't shining? That's where calculating days of autonomy comes in. It helps you figure out how long your system can run without any help from the sun or wind. First, you need to know how much energy your appliances and devices use each day. Add up the power ratings of everything you plan to run in watts and multiply by the hours they operate daily. This gives you the total energy in watt-hours or kilowatt-hours. For example, if your fridge uses 150 watts and runs for 24 hours, that's 3,600 watt-hours. If your lights and other devices add up to 1,800 watt-hours, your total daily energy use might be around 5,400 watt-hours. Next, decide how many days you want your system to keep you going without any input from renewable sources. This is your desired autonomy period. Many off-grid setups aim for 2 to 5 days, depending on weather patterns and location. If you want 3 days of backup, multiply your daily energy use by 3. Using the previous example, 5,400 watt-hours times 3 equals 16,200 watt-hours needed. Now you need to determine the size of your battery bank. Since batteries shouldn't be fully drained, you need to consider the depth of discharge. For lead-acid batteries, a safe discharge limit is about 50%. Lithium-ion batteries can go up to 80 or 90%. So, divide your total energy requirement by this percentage to find the actual capacity needed. For example, if you need 16,200 watt-hours and your batteries are 50% dischargeable, you'll need 32,400 watt-hours of storage. Then, account for system inefficiencies. Inverters, wiring, and battery performance can cause losses of 10 to 20%. To be safe, increase your battery capacity by this percentage. If you add 20% to 32,400 watt-hours, you get about 38,180 watt-hours. Finally, convert this energy capacity into ampere-hours if you know your battery voltage. Divide the total watt-hours by the voltage. For a 48-volt system, 38,880 watt-hours divided by 48 volts equals 810 ampere-hours. That means you'll need a battery bank with at least 810 ampere-hours capacity at 48 volts to meet your 3-day autonomy goal. This calculation ensures your off-grid system can supply power during cloudy days or when renewable sources aren't available. Remember to consider local solar or wind conditions, temperature effects on batteries, and your actual load to fine-tune your system size. By following these steps, you'll build a reliable energy reserve that keeps your off-grid life running smoothly, no matter what the weather brings.